Alrighty, hey everybody. Sorry we're starting a couple of minutes late. I hope all is going well. As you can see, I'm in a kind of a different environment than our usual classes, sitting next to a bunk bed in my parents' house. So a little bit out of the groove of being in my office and whatnot, but we'll still have a good class today, talking about custom data types. So hopefully everything went well with the homework last night. I know a few of you reached out to me, maybe a little frustrated or stressed, because it was definitely a challenge. And so if you do have specific questions about it, about the homework, feel free to reach out to me or to any of your PMs, and they would be happy to help out. We obviously don't want to give you all of the answers, but we're happy to walk you through it, and help you figure out why, how to create that function that finds the synonyms, or really how to interpret the dictionary that has a string key and an array value. I know that kind of threw some of you off. So believe me, I understand it was probably one of the more difficult challenges, so we're happy to help out as needed. So feel free to reach out to us. I'm trying to think if we have anything else we need to bring up. Again, if you are looking to do the full-time course, make sure that you go and sign up online for that. Tomorrow is our last day of class. And then, you have completed what we feel is necessary for you to be able to take the full-time course. And so if you do apply, you'll be given just a code challenge, and the things contained in that challenge will be a lot of what we've already learned. So that's kind of one of the purposes of this class. Besides kind of giving you an intro to Swift, it will help you prepare for the full-time course as well. So let's go ahead and let's get into it here. I only have one screen here, so I'm going to do my best to share my screen, but I still want to have my notes up next to me. And so let's see if I can figure out how to do that in Zoom here. So I'm already sharing my screen here. Let's do a new share. And we are going to be sharing from Xcode, okay? So like always, let's go ahead and let's open up Xcode. And we're going to be starting a new playground, okay? And let's go ahead and call this playground, and I'll share it with you in just a second. We're going to call this playground custom data types, okay? And then you can just save that wherever you save all of your other stuff that we've been working on up to this point in the course. Okay, and then let me see if I can get this to share properly now. Okay, so I've shared my screen. Are you guys able to see it? What does it look like on your side? Does it look good? Is it too small?
We see just the Xcode.
You see just the Xcode. That's okay. But are you able to see the text, or do I need to make it a little bit bigger?
No, it looks pretty good.
Okay. Alrighty, cool. So let's go ahead and let's talk about custom data types. So let's go ahead, and I'm just going to label this custom data types. Okay.
Hey, Johnny?
Yeah.
Can you change the background? You have it as the dark background right now?
Oh, yes. Let's change that here. Presentation large. Okay. Great. Thank you, guys. Okay. So today we are going to be talking about custom data types. So up to this point, we've been working with data types that the Apple has built in for us, right? So we've been working with strings, we've been working with integers, we've been working with bools. So those are all different data types. So again, if I create a variable here and say variable name equals Johnny, well, we know that the type to name, and if we option click on it, is going to be of type string, right? And so string in and of itself is a data type. So today we're going to talk about how we can create our own data types. And the first way that we can do that is by creating something that's called a struct, okay? And so struct is short for structure. And so let me show you how to set up a struct, okay? So like most of the things that we've been working with, it's pretty easy. If we start typing in struct, it will autocomplete for us. And so that's the keyword to begin a struct. Now, what comes after this keyword struct is going to be the name of our class. So, just like we have string and we have int, we have bool. We're going to go ahead and name this struct. And so let's go ahead and say person. Let's create a person struct. And you'll see here that I didn't use camel case. I actually started it with a capital P. And that's pretty common when you're creating structs and classes or these custom data types, is that the specific data type is going to start with a capital letter. Okay, so I've got person, and then to create the body of our struct, we're going to create 2 curly braces. Okay, so this looks pretty similar to like when you set up a function, right? Is you've got the curly braces, you've got the name. Looks like we're omitting the parentheses. That's kind of the only thing that's missing, right? The general framework of a function, right? So this data type now, this person data type, is now going to have a few properties inside of it, right? And so with any person, a person always has a name, okay? And we're going to say name of type string, and we're going to say that our person type also has an age, which is of type int, okay? And most of the time you're going to want to have these properties inside of here be variables rather than constants. And we'll talk a little bit more about that later. But it's pretty common in structs to always have your properties set as variables, okay? So this struct now has 2 properties inside of it. So our person has 2 properties inside it. Let's talk about methods, okay? And so trying to think what day it was. Well, we've probably covered a little bit of it every day. So methods are just another name for functions, okay? What makes methods different is that they are inside of specific classes or structs, right? And so an example of a method we talked a little bit about yesterday, but let's say I have an array here of names, okay? And because array is of type array, I have access to all of the methods that are inside of the array type, right? So when I type array and then a dot, this will give me access to the different methods that Apple has built in for us on these array types, right? So we have the contains, or when we did remove, those are all methods inside of the array type, data type, okay? And so now we are creating our own custom method inside of our custom data type, right? So let's go ahead and let's create a method here. And just like with functions, we started off with func, and we're going to give it a name. So let's call this function or method introduce. It's not going to have any parameters, and we're not going to have a return type either. And then let's go ahead and print out my name is, okay, and then using string interpolation, we're going to throw in our name property here. And I am, and some more string interpolation, we're going to throw in our age property here, years old. Okay, so now I have an instance or now I have a method inside of my person struct that I can call whenever I create an instance of my person data type. Okay, so let's go ahead, and now that we've created our first struct here, let's go ahead and let's practice creating another struct. Okay, so let me go ahead and let's enter a few times here. Okay, now let's create another structure here, and let's create a struct for a song. Okay, so let's go ahead and say that I have struct song. Okay, and so what are some things that a song contains? Well, we've got a title, right? So we've got a title, which is going to be of type string. We've got an album, and this is going to be of type string optional. And the reason that we want to do string optional here is because sometimes we have songs that don't have an album, right? So if like an artist releases a single, there's often not an album tied to it. So that's why we're going to make our album property an optional. Okay. What else do we got? Let's do artists. Okay, which is going to be of type string, and yeah, let's go ahead and leave it at that. Okay. So this is how we create a struct. Okay, so this is going to be our song struct. Alrighty, so let's go ahead and let's talk about how we can instantiate or create an instance of these classes. Okay, so how we can create an instance of these classes. So let's go ahead, and I'm down here outside of any of my structs. Let's say that we have a property called friend. Okay, so let's say let friend equal, and I could do this, I could say of type person, right? But we don't necessarily need to do that because the compiler can usually infer what we're trying to do. And to create an instance method of friend, I'm going to call my struct, so person here, and then I'm going to do an open parenthesis. Okay? And so as soon as we do that, you see that if we want to create an instance of person, it's going to require a name and an age, which is exactly what we'd expect, right? Because those are the two properties that we have inside of a person. Okay? So go ahead and we'll do person, and let's say we've got Joe, who is 33. Okay? So what happens if I want to change, say I want to change one of these properties? Well, I'll go ahead and I'll call my instance here of person, right, which is friend. And I'm going to do friend, and then to access the different properties inside of our friend object, I just use dot notation, right? And you can see that I can access the age and the name. And then if I wanted to, I could also do introduce, right? So what happens if we call this introduce here? Well, if my Xcode will work, we could see that it will print out an introduction to our friend. Though, I don't know why this is having so many problems. I felt like we were really good last week, didn't have many problems, and then this week just has not been working well. Okay. All right, I might need to restart Xcode real quick. Hold on just a sec. Okay, give me 1 minute here to relaunch Xcode. And we're going to be looking at custom data types. And let's stop this and manually run. Okay. Alrighty, let me go ahead and share my screen here again. Yeah, this is so much harder without a second monitor. Okay. So we are in here. I'm going to share my screen. Okay. So you should all be able to see my screen again. And I'm going to go ahead and run my code. And you'll see that when we call our method that was inside of our person data type, we get that method for us that says, my name is Joe and I am 33 years old, right? So it took our parameters that we had passed in, Joe, age 33, it took those properties and inserted them into the method, which is exactly what we expected, right? So let's say, for example, that Joe recently turned 34. So I'm going to go ahead and I'm going to call my friend, and then I'm going to say friend.age is equal to 34. Well, we're going to see a problem here. It says cannot assign to property friend, because friend is a let constant, right? So you can see here that we made our friend a constant, okay? And so what that does in a struct is it makes it so that we can't change any of the properties inside of it. Even though those were set as variables, my instance of a person as a whole is set to a constant right here, right, with let. So if I change that to variable friend, then it means that I can make changes to the properties inside of friend. Okay, so I can change this friend.age to 34, so that if we print out my friend.age, we should see that he is now 34. Okay, so previously, before we did that, if we print friend.age, we'll see that he was 33, but then we changed his age to 34. Okay, so let's go ahead and let's instantiate or create an instance of our song property. Okay, so someone just asked, can I do friend.age plus equals 1? Okay, so that's a good question. Let's go ahead and try it. Let's do plus equals 1 here and run our code. And we'll see that we can indeed do that as well. Okay, so we can either set it directly at 34, or we can add, because it's an integer, right? We can perform arithmetic on it. Alrighty, so let's go ahead and let's instantiate or create an instance of our song. Okay, so I'm going to go ahead and I'm going to create a variable here. And we're going to say favorite song is going to be equal to song. Right, so I've got my song data type, open parentheses, and then we can see what's required here is a string, an album, and an artist. Okay, so let's say I really like the song Thunder, and this is part of Imagine Dragons' album Evolve. Okay, and our artist is Imagine Dragons. Okay, so now our favorite song, again, is of type song, okay? And all of these properties inside of them, so if I go ahead and I print out favorite song dot title, we can see that the title to my favorite song is Thunder, okay? Let me just make sure, okay. Okay, any questions up to this point? I'm trying to keep an eye on the chat as best I can. Okay. Alrighty. Oh, let's see here. Just had a chat come through. Okay. Alrighty. So now that we have talked about that, let's go ahead and talk about how we can create custom initializers. Okay. And so an initializer is what we used in order to create an instance of our data type, right? And so when we went here, so when I did song right here, this is called an initializer. And so the initializer is what you use to create an instance of a specific data type, okay? And so when we have a struct, structs are really nice because they actually create what's called a member-wise initializer for us. Okay, and so that's just a standard initializer that takes all of your properties and then asks you to give values to each of those properties. Okay, but what if I want to create my own initializer? Well, let's talk about how we can create our own initializer. Okay, so I'm going to get rid of this code for a sec. And to get more practice creating these structs, I'm going to create a new struct here. And this struct is going to be called vehicle. Okay, so let's go ahead and we're going to start this out by saying struct. This is going to be vehicle. Okay, and then what are the properties of a vehicle? Well, we could do number of doors, or number of wheels. Okay, and that's going to be of type int. And this needs to be a variable, right? Variable number of wheels of type int. Variable number of doors is also going to be of type int. And let's say that our car also has a color, right? Variable color of type string. Okay. So in order to create an initializer for this, okay, we need to start off with the keyword init. Okay, so init is short for initializer. And then you can see that init even more so looks like a function, right? It has parameters, and then we have statements inside of the braces. Okay, so in our init, we need to put in parameters. Okay, and so the things that I want to pass through when I'm initializing a vehicle is I want to pass through all of my properties, right? So let's go ahead and say number of wheels is one of my parameters, and it's going to be of type int. Number of doors is also going to be of type int, and then color is going to be of type string. Okay, and so then it's going to ask for what statements we want in here. Okay, and so I'm going to say, well, self.number of wheels. Okay, and so when I'm saying self here, I'm saying this number of wheels, right? Okay, so self.number of wheels is equal to the number of wheels in my parameter. Okay, so self.number of wheels equals number of wheels. Self.number of doors is equal to number of doors, my number of doors parameter, and self.color is equal to color. Okay, so this initializer right here is the exact thing that the member-wise initializer that the struct creates for us is doing, right? So this is pretty repetitive. So if, for example, I want to go here and I say let car equal vehicle. Okay, so then we have that initializer here with number of wheels, number of doors, and color. Okay, so that's exactly what we just created. It looks the same as the one that's already created for us. Okay, but what if I wanted to make a modification to this initializer and I wanted to give it a default value for one of for its color, right? So let's say I want the default color for all vehicles to be equal to black. Okay, well, I can go ahead and I can set that default value here in this initializer, saying to initialize the color with black. Okay, so now if we go down here to our vehicle, you'll see that I have two different initializers. Okay, so I have this initializer here, which is just the default one that struct creates for us. But then I also have this member-wise initializer that this initializer that I just customized and created here, right? And so you can see that now I have two options when I initialize a vehicle. I can either initialize it with the number of wheels, the number of the doors, or color, or if the color is black and I don't care about the color, I can just initialize it with this initializer that just asks for the number of wheels, which is 4, and the number of doors is 2. Okay, so that is an example of creating our own initializer. Okay, and so just a quick note with that. All non-optional properties need to be assigned a value. Okay, so you may wonder, well, why did I have to do self.color equals color if I have color set with something default up here? That's because color in this case is not an optional. Okay, but if number of doors was optional, whoops, it doesn't go there, right here. If number of doors is optional, then I can get away without doing self.number of doors equals number of doors. Is that right? Let's see here. Self.number of doors equals number of doors. I don't know why it's getting mad at me here. Return from initializer without initializing all stored properties. Let's see. Why is that? Okay, I'll have to get back to you on that. I'm not sure why that's not letting me return. So if I do self.number of doors, oh, I need to at least give it a default value, right? So even though this is optional, if I give it a default value of 2, and then we say self.number of doors equals number of doors, then let car2 equal vehicle. Okay, yeah. So you can see here that now, because number of doors is optional, and I gave it a default value, I can just I can initialize an instance of this vehicle without needing to include either my color or the number of doors. Okay. All right. So let's go ahead and let's go ahead and create a custom initializer for our song struct. Okay. So let's get rid of all this. Okay, and we want to create a custom initializer here. Okay, so the way that we do this, remember, is start with init, and then we want to go ahead and bring all of our properties in as parameters, right? So title, string, album of type string, and it's an optional, right? And we'll say that its default value is equal to nil. Okay, and then artist is also going to be of type string. Okay, and then always we're going to do self.title is equal to title, and self.album is equal to album, self.artist is equal to artist. Okay, so now let's see what happens when we try to initialize a song. Let favorite song equal song. Okay, and so first you'll see the member-wise initializer that is created for us with title, album, and artist. Or I can initialize it without an album, right? With just the title and artist. Because album is an optional and it has a default value of nil. Okay? So usually right here, you're always going to want to initialize each one of these with the self, with the property that you already have on it, right? Okay, so let's go ahead then and let's talk about classes. Okay, so that's all that we have on struct. So remember, struct, start with the keyword struct, and it includes all of your properties and your methods. And structs do not require you to create a custom initializer because a member-wise initializer is provided for you. Okay. So let's talk about classes now, okay? So if I want to create a class here, say I have class and let's just do person again. Class person, and it has variable name of type string and variable age of type int, right? Well, if I tried to do what I did previously, so if we say let name equal person here, sorry, I already have person up here. It's saying you can't do that. Clear that out here. Okay, so if I try to finish off this class, you'll see that it has an error here, and it says person has no initializers. Okay, so this is one of the differences between structs and classes, is the class requires you to create your own initializer. Okay, but we're getting pretty good at that, so let's go ahead and let's just create the standard member-wise initializer, which looks like this, right? So we're going to have our name parameter of type string, we have our age parameter of type int, and self.name is equal to name, and self.age is equal to age. Okay, so now we can create an instance and say let friend equal, let friend2 equal person, and there's our initializer, right? So we can pass in a name and a string, each 25, okay? And now I have an instance of my person class here, okay? So let's talk about the difference here. So when we have classes, remember with structs, if I wanted to change a property inside of my instance of the struct, I needed to make sure that my stored property here was a variable, right? Well, the nice thing about classes is that that can be a constant, right? So let's say that my friend's age is now 26. Okay, let's print out friend2.age and run the code, and you'll see that now that's showing as 26. Okay, so that's another difference between structs and classes, is that structs require the instance to be a variable if you want to change any of the properties, whereas classes allow you to change the properties within the instance, even if the stored property is a constant, right? Okay, so I can also change my friend2.name is equal to Ness. Okay, and we can print out friend2.name, and we see that it's Ness, right? Okay. I'm trying to think what else needs to be covered with these classes here. Okay, so the only thing that you can't change, for example, is if we have friend2 up here, I can't do this. I can't say friend2 equals person. Okay, I can't create a new instance of I can't replace this property with a new instance, right? So I can change the properties inside of the instance, but I can't make it a new instance by itself, right? Okay, so if I have Johnny 24, well, this is going to say, hey, you can't do that, right? You cannot assign value of friend2 as a let constant, okay? Alrighty, so let's go ahead and let's do a challenge here. Challenge, okay. This is kind of a big one. So I'm going to give you 7 minutes to work on it. Okay, so this is your challenge. I want you to create a struct called bottle. And you're going to give it two properties, volume and water level. Okay, and then I want you to create a let constant, and what I'm saying that is we're going to be creating a new instance of bottle, right? And that's going to be called bottle1. And you're just going to use the member-wise initializer that's given to you. Okay, and then I want you to use a print statement to print the water level in bottle1. Okay. Next, you're going to create a variable called bottle2 and assign bottle1 to it. And then you're going to use a print statement to print the water level in bottle2. Then you're going to change the water level in bottle2 to something else, and then use a print statement to print the water level in bottle1 again. Okay? So go ahead and take about 7 minutes to do this challenge. Let me know if you have any questions in the meantime. All right, guys, let's go ahead and run through it. Okay, so we're going to start out by creating a struct here. And our struct is going to be bottle. Okay, and then we've got two properties in it, right? We've got the volume. Okay, so variable volume is equal to, let's have this be double. Okay, and variable water level, not equal to a double. Just want its type to be a double, right? Water level is also going to be, well, it's going to be a percentage, so we'll do double, right? Say that it's like half full. Alrighty, so we've got our bottle struct. We don't need to add anything else to it right now. So let's go ahead and we're going to create a constant here for bottle 1. That is equal to bottle. And let's go ahead and say that its volume is 12 ounces. Okay, and the water level in this case is going to be 0.5. So it's half full, right? Okay, and then let's say here that I have a variable that's called bottle 2. And bottle 2 is going to be equal to bottle 1. Okay, so let's go ahead and first we want to print out the water level in bottle 1, right? So we're going to do bottle 1 dot water level, and we should see that that is 0.5. Okay, and so bottle 2 is equal to bottle 1, and let's print out the water level in bottle 2. Bottle 2 dot water level. Okay, so 0.5 and 0.5, so that seems right. Okay, let's go ahead and let's change the water level in bottle 2. Say bottle 2 dot water level is now equal to 0.3. Okay, and print out bottle 2 dot water level. Okay, so if we run that, then we should see 0.3. Okay, well, let's print out, so we've changed the water level in bottle 2, but let's see what the water level is in bottle 1. Okay, we see that it is still 0.5, okay, which is perfect. So we changed the property in bottle 2 and it didn't affect what was in bottle 1, even though bottle 2 was equal to bottle 1, right? So it almost created its own, it created its own value for its water level. Okay, so even though it got its original water level from bottle 1, it has its own water level. Okay, well, let's change struct here, the struct of the bottle, to a class and see what difference this makes. Okay, and so remember, with class we need to add our own initializer. Okay, so we have volume double, got water level double here, and we'll say self.volume. Volume is equal to volume, and self.water level is equal to water level. Okay, so let's go ahead and run our code again. Okay, so remember, the last thing that this is printing here is bottle 1's water level. Okay, and so previously it was 0.5, right? Because when it was a struct, changing the water level of bottle 2 did not affect the water level of bottle 1. But with a class, this did actually affect, changing the water level in bottle 2 did affect the water level in bottle 1. And that illustrates one difference between structs and classes. Is structs are what we call value types. Okay, and so value types, it means that we can change a property in one without it affecting the property of another instance of that type, right? So bottle 1, bottle 2, we're able to change the water level in bottle 2 without it affecting bottle 1, okay? But classes are what we call reference types. And so when I say value types and reference types, I'm talking about a specific stored value in memory, okay? So in a struct, when we create a new struct and we create an instance, it creates a new value in a new location in memory. And so that's why bottle 1 and bottle 2, they seem to kind of be mutually exclusive, right? I can change, even though one is set to the other, I can change a property in one without it affecting the other. And that illustrates what's a value type, okay? And that value is a location in memory, okay? But with a class, it doesn't seem that bottle 1 and bottle 2 are mutually exclusive anymore, and that's because classes are reference types. And so we are referencing the value in memory for one, as well as for bottle 1, as well as for bottle 2. And so when we make a change to bottle 2, it also affects that piece of memory in bottle 1, okay? So I know that's kind of a lot to take in. Don't worry too much about that, but this is just a good example to illustrate the difference between structs and classes as far as reference types and value types, okay? So the question is then, why would we ever want to use a class? If we have to create our own initializer, ew, like who wants to have to do that? Let's talk about that. Okay, so classes are pretty darn awesome because classes will allow us to create subclasses on them. Okay, so I'm going to go ahead and I'm going to create a class here. And we're going to say my class here is animal. Okay. And for the sake of time, I'm going to cheat a little bit, and I'm going to put in these new properties here. Okay, so our animal has a property species, number of legs, has a bool property of whether it has a tail or not, and then we need to create a memberwise initializer for it. Okay, so this is just the same initializer as we always did. So we've got species of type string, number of legs of type int, has tail of type bool, and we gave it a default value of false, right? And then we're just going to say self.species equals species, self.number of legs equals number of legs, self.hastail equals hastail, okay? And then I want to go ahead and let's create a method on this, and we'll call it vocalize. Vocalize. We don't need any parameters. We don't need a return type. And let's go ahead and print out I am a, and then pass in our species property, right? So I am a canine or whatever, right? So that's a method that we have on our animal class, okay? So, like we did previously, if I wanted to say let my dog equal animal, and then I have this instance method, I can either do I can do the memberwise one, which we can see includes has tail, or if I don't want to give it a tail, I can just do the number of legs, okay? And my dog does have a tail, so let's go ahead and let's call this canine, 4 legs, has tail equals true, okay? And so there's an instance of my dog, okay? But let's say that maybe this animal class, it has some of the things that I want. So some of these are important, like the species, number of legs, has tail, and this vocalize method is pretty good. But I want to create a subclass because this doesn't really give me enough to create like a good data type that has all the information I need, okay? So what we can do now that we have our animal class is I can create another class, and let's just call this dog, okay? So I have a dog class, and then this is what we do to create a subclass, okay? So we do colon, and then I'm going to put the subclass, okay? So now I have my class, which is dog, and it's a subclass of animal. And so when we say that it's a subclass, it means that it inherits everything inside of this animal class, okay? So that's really nice because now I don't have to reinstantiate species, number of legs, has tail. Rather, I don't have to worry about that because that will all be done for me by this initializer. And I can add new properties that are more specific to a dog, okay? So let's go ahead and say I have another variable, we'll say name, and my dog has a breed, just type string, as well as a color. Okay, variable color, type string. Okay, and so I do need to create an initializer for my dog class, right? Because I need to, whoops, let's see here, go back. For my dog class, because my name, breed, and color properties have not yet been initialized, okay? So I'll go ahead and I'll call init here, and we want to initialize the name. Just give type string, breed of type string, and color also of type string, okay? And then we can go ahead and say self.name is equal to name, self.breed is equal to breed, and self.color is equal to color, okay? And then you'll see that we still have an error, okay? And it says superinit isn't called, okay? And so we also, when we're creating this dog class, because it inherits from animal, I need to initialize a default value for dog, right? So what I can do here is I can say super, which means go to my super class dot init, and then you can see that now I can initialize all of these properties that were in my animal class, right? So we know that a dog is a canine, has 4 legs, and some dogs don't have tails, but we'll just say that has tail is equal to true. Okay, so that's all set up for me so that now when I create an instance of dog, I don't need to include the species, the legs, and whether it has a tail. I only need to include the name, breed, and color, okay, because this has already been initialized for me. Okay, and let's go ahead and let's say that we want to, this vocalize function is good except that dogs can't talk, right? And so if ever we want to use a method, but we want to change it a little bit, we use a keyword called override, okay? So I'm going to override my vocalize method, okay? So I'm overriding vocalize so that in any instance of dog, it's not going to print out I am a dog, rather it's going to print out woof woof, right? So vocalizing is going to be different for my dog than if it was some other animal or other species, right? So we override that method to say woof woof, okay? So let's go ahead and let's create an instance of my dog now. So let's say let beagle equal dog, okay? And so then we need to include a name, a breed, and a color. Okay, so let's call him Eddie, and he is of the beagle breed, and he is brown. Okay, so now I can go ahead and I can print out my beagle.name, and we'll see that my beagle's name is Eddie. I can print out beagle.breed. And we see that he is of type beagle, right? He's a beagle breed. And then let's go ahead and let's call beagle.vocalize. See what we get, okay? Woof, woof, okay? So beagle, woof, woof. So even though this vocalize originally was I am this species, because I overrode the function in my subclass here, it prints out woof, woof, okay? Alrighty, so that is the beauty of classes over structs, right? Is this ability to subclass. So I could do this again. I could say, okay, all right, so I've got my dog class. Let's go ahead and make another class of cat, okay? And it's a subclass of animal, okay? And you can even subclass another subclass, okay? So I've got dog, but let's say that I want to create a class for Labrador, okay? So class Labrador, and it's going to be a subclass of dog, okay? So this is what's so awesome about these classes, is that you can continue to create classes and subclasses under those, so that you don't have to repeat code, so that you can initialize these properties using things that have already been initialized for you, okay? So the question is when to use classes versus structs. Well, remember, keep in mind the value versus the reference type, okay? But you won't need to worry about that one very much in the scope of this course, okay? But if you are going to need to create a subclass off of something, then be sure to use a class, not a struct, right? And then you also would want to use a class if you need to create your own initializer, okay? Which you can create your own initializer for struct, but usually you just, if you have something custom, you can put that in the struct or the class. So actually that's not really a reason why you would use one over the other, but the reference versus value type, as well as the need for subclassing, okay? Anyway, so let me go ahead and stop sharing my screen. Okay, so I'm going to go ahead and post your homework for tonight that will help you get a lot more practice with using classes and structs. Okay, so your homework here is a project called Structs and Classes, which is perfect. Okay. And this is really important homework because we're going to be referencing it tomorrow for our last day of class. Okay, we're going to do a guided project tomorrow, and we're going to be using some of what you learned in this for this contact application. Okay, so let me go ahead and in the chat here, here's your homework. And I will also include that in Slack. Homework. Okay, and that is all that we have for tonight, guys. I'm sorry if this lecture seemed a little bit less organized. I've been working on just my single computer screen, which is a little bit harder. But thank you for your patience, and if you have any questions about classes and structs before our class tomorrow, feel free to reach out to me or to any of your PMs who will be happy to help you out. So best of luck on the homework tonight, and we will see you all tomorrow for our last day of class. Take care, guys.